Greetings, students. We're going to start with section 2.01a, and I break this section down into 4 different parts. The first video is just going to be a review of material that you would learn in a college algebra class. In calculus, we do so much with functions throughout the semester, we need to make sure we know what a function is. Okay, and I hope you enjoyed the musical introduction. I always put some little guitar thing in here somewhere. All right, so to begin with, what I'm going to go ahead and look at is just remind you of what the definition of a function is. So a function is a correspondence between 2 sets of elements such that each element in the first set corresponds to one and only one element in the second set. The first set is the domain. The second set is the range. And I'll go through what we call mapping diagrams to help you understand visually what we mean by a function. So basically, the domain of a function is the set of the first elements. Think of the first elements as inputs in a Cartesian plane, which just means a graphical system, XY coordinate system you're familiar with. The domain is going to be the set of all x values. Okay, and the range of a function is the set of all second elements. We call that the outputs. In a Cartesian plane, this is the set of all y values. Okay, so down below is an example of a mapping diagram. A mapping diagram, we have inputs represented by our x values, and we have outputs represented by our y values. Inputs are independent variables. The outputs are dependent variables. That means the result of the output depends on the input. All right, and notice on this one that every element just maps to one. We call this a mapping system like that. So this item right here, this input has one output. This input has one output and so forth. So if every input has exactly one output, then that's what a function is. Okay, so let's go down and look at these examples. So example 1a, we have these inputs, we have these outputs. So all you do is you ask the question, does each input have only one output? So the 10 goes to 15, 20 to 45, 30 to 25, 40 to 35. So that's certainly the answer to that is yes. So that means that this is a function. The domain, typically we do a domain in set braces. So you just write a brace. You want to put this in numerical order. You don't have to, but it's preferred that you do that. The range would be all of the outputs. So that would be 15, 25, 35, and 45. Okay, and then we go to part B. So we ask the question, does each input have only one output? Well, the answer to that is no, because notice this negative 35 has 2 outputs. It has an output of 1 and it has an output of 22, so that's not a function. All you got to do is find, it kind of works like this, real simple. If you see like an input that's going to 2 places, then it's not a function, okay? Or it could go to, more than 1. It could go to 3 places like that. Okay, the domain, again, is the set of all the x values or the inputs. So that's negative 35, negative 5, 0. The range is the set of all y values or outputs. So that's 1, 4, 22. Okay, and then the last example, does each input have only one output? 1 goes to 5, 2 goes to 7, 3 goes to 7. It's okay that both the 2 and 3 go to the same output. So this is a function. Every input has exactly one output. The domain would be 1, 2, 3. The range would be 5, 7. Okay, so that's what we mean by a function. When we're dealing with calculus, we'll be dealing with functions throughout the semester. So you need to know what one is. Okay, you can pause the video at any time that you need to, and you can rewind on YouTube. It's very easy to navigate through the video. So I'll go to the second page, and one thing I like to have you do a lot of times is just simply work out problems, and I'm going to have you go ahead and work out these. What you want to do is you want to pause the video, and then you want to resume as soon as you're done with these. And then I'll have the answers posted on that, okay, for you to check. But when you're following a video, it's real important that you do this. See if you absorbed what I just taught. See how you're doing, kind of give you a little bit of feedback on how well your understanding is. Okay, so good luck. Okay, so you can go ahead and check your answers and see if you did this okay. I'll just kind of quickly go through this. Number one is a function. The domain is all of the x's for a 12. The range is the y, 0, 10, 20. Number two is also a function, even though all of these guys really like Kathy. Kathy's a lucky girl. It's still a function in this regard. So each input has one output. That one output is Kathy. Okay, and the domain on this is the first elements, Ken, Carl, and Lewis. And then the range is Kathy. All right, let's see. Next one, number three, is not a function. And again on this, Jerry, he kind of likes girls a lot. So he likes three different girls, Abigail, Barbie, and Jill. So Jerry's kind of a bad guy. He's a real bad boy. That's not a function, okay? And again, with this, the domain is Jerry, and then the range would be the three girls. Okay, like that. Example number four, what we have on this is a function. The domain is all of the x's, and the range is the y's. Now notice on the range, I don't write 2, 4, 2, 4, 4, 2. I just write the two elements, okay? If it's helpful to you to do this, you could write all of the x's down and the y's, and then just do a mapping diagram like this. So basically, the -2 only has one output, -1 has one output, and so forth, okay? You would have to have something kind of like this, like if I had a 2 and a 7, then that would cause this not to be a function, see? Okay, on that. Okay, so that's it. We're going to go ahead now and go to the next page. And what we'll look at on the next page is just a little bit more on functions. We'll look at the vertical line test next here. Okay, so what a vertical line test is it's taking the definition of a function and showing you how you can use a simple technique to tell if a graph is a function or if it's not a function. So it goes like this. If any vertical line passes through exactly one point, then the graph represents a function. And the key on that is any vertical line, or every vertical line you draw can only go through one point. And that's basically because every x can only have one y. It can't have two y values. And then if you can find a vertical line, and all you got to do is find one that passes through two or more points, then it's not a function, okay? So this goes like this. If you go to this example 2, all you got to do is find a vertical line that goes through two or more points. So notice this point is about 2. That looks like it's 2, and maybe it's 2.5. I'm just estimating. And then this point right here is 2 and -2.5. So what you see is the same x has two different outputs. So that is not a function. That fails the vertical line test. Okay, the next one, and the thing on this is it doesn't matter where you draw your vertical line. Notice that you're only touching one point every time you do that. So that means that every x has exactly one y. So that is a function. On C, same thing. I'll zoom on this a little bit. This is something you would see in a business calculus class a lot, is where you might have average cost. This is a graph of an average cost function. So again, this is a function. Every single vertical line that you can possibly draw is going to go through one point only. So that is a function. Okay? And then the next one, this is something you wouldn't see in a business calculus class. This is called a cardioid. And by the way, the microphone that I'm using is what we call a cardioid microphone, and it has a pickup pattern that looks like this. So if you're interested in learning about cardioids, just Google it sometime. It's kind of interesting. Mathematics is everywhere, and my cardioid microphone I'm talking through right now is picking up from one direction. Okay, well anyway, this is definitely not a function. Notice that you have two different y values for one x, so that fails the vertical line test, so that's a no. Okay, now we go to, I'm going to go ahead and move down to the bottom of the page, and I want you to go ahead and do this problem yourself. What I want you to do is plot the points, just to make sure that you know how to plot points, and then ask yourself, is this a graph of a function? And then see if you can answer this. If it's not a function, are there any points you could take away that would make it into a function? Okay, so we'll go ahead and, again, pause the video, work these problems out, and then check. Okay, so here's the results that I hope you had. The first thing that you want to do is check your drawings. All right, plotting your points right here. So A, that has an x value of -4 and a y value of 5. So you always start in the middle and you go to the left 4 and then up 5, and then you put the point A like that. Point B, you're going to the left -3, and you're not moving up or down on the y-axis. So if that y is 0, this is what we call an x-intercept. Okay, C, you would go left 4, down 5. So notice I went left 4 on the x-axis, down 5 on the y-axis. Point D is in the middle, 0, 0. We call that point the origin. And then -3, 3, you're going to the left 3, up 3 on y to get that point. F, you're going over 1, up 4. G, you're going over 2, up 4, like that. So the thing on this is this is not a function because of this problem right here. There's two places where vertical lines go through 2 points. So it's not a function. Now what you could do is you could take off either A or C, and you could take off either E or B. It doesn't matter which one. So you just have to take off either A or E. Just make sure that you're going to pass the vertical line test. Okay? All right. So now I'll move to the next page. And that's where this video will stop. Second part of the video, we will pick up on the calculus with the idea of a limit. All right. Hope this helped to give you a good review.